for the third video of this series.
As I said, it's a series of videos on electrostatics.
In this video, we'll speak about the Gauss law and its applications.
So this is Gauss law, statement and proof. The statement is that for a closed surface, if capital Q is the charge enclosed by the surface, then the flux coming out of the surface is 1 by epsilon naught into Q, the charge enclosed by the surface. So here we can find that if capital Q is the charge, then the flux will be Q by epsilon naught. That's a mathematical expression. Okay, fine. Then where this epsilon naught is the absolute permittivity of free space, as we know. And now how to proceed to prove the law. Before that, we'll consider a figure. This figure where Qi is the charge, and this is a whole surface here, and out of this whole surface we take a very small surface element here, ds, shown by this solid line, and this Ei is the electric field due to Qi, and this n cap is the normal to the surface ds, and theta is the angle between Ei and ds vector, and r is the distance between this charge Qi and the surface element ds. Now coming back to this main thing, since the Qi is a charge, definitely it produces an electric field, and at the point where ds is situated, let me say that point is P. So the point P, the electric field will be by definition 1 by 4 pi epsilon naught Qi by r square. So let me say that this point is P here, and that's where the surface resides. Okay. So this is the electric field where Qi is the charge and r is the distance between point P and the source. So through the surface ds, as by definition the flux will be Ei dot ds. This is a vector product, and Ei ds cos theta. Theta is already shown here. And ultimately putting the expression of Ei from equation 1, we get back this relation Qi by 4 pi epsilon naught ds cos theta by r square. Now this quantity ds by cos theta by r square is nothing, it's a solid angle. You can see that in the figure that a solid angle is actually generated here. This is a solid angle, just like the angle in an ice cream or this kind of conical structure. So this is a solid angle subtended at the point in this surface area. And when we integrate this quantity over a whole surface, then we get 4 pi. That means if we integrate this for a whole surface, we get 4 pi, and this is shown by expression 3. So integrating that equation 2 and using equation 3, we get the total flux for the whole surface due to charge Qi. So you just look at equation 2 and integrate this equation. The integration of this equation means, we just remember that equation 2 represents flux to the surface ds. When you integrate that, it means we are getting the flux for a whole surface. So we are integrating this, and we are getting the whole flux for the whole surface S, and this is only because of the charge Qi. So the integration is 4 pi, and ultimately 4 pi cancels, it is Qi by epsilon naught. Now equation 4 represents flux due to Qi through the whole surface. Now our question was that if instead of Qi only there are lots of charges inside the surface, then we have to sum up all these fluxes. So to that end, we can see that if we take all the charges inside the surface, we will find a total flux, and for that we just add up all these fluxes and this Qi by epsilon naught, and ultimately this Qi when sum over all the charges will give the Q, capital Q, which will be the total charge. So Qi simply represents Q1, Q2, Qt dot dot dot, and all these charges Q1, Q2, Qt is all together making this as capital Q. So total flux for the whole surface due to all the charges inside the surface is nothing but F equal to Q by epsilon naught. So thus it proves the Gauss law, which states that the flux coming out of a closed surface is equal to charge enclosed by the surface divided by epsilon naught, absolute permittivity of free space. So with these ideas, we can conclude that first thing we conclude is that area can be made as a vector. We just do a unit outer normal vector. This will represent the direction of the area, and just area becomes a vector. And then we define what is electric lines of force. They are just simply pictorial representation of charge distribution and the electric field present in the region of space. It may be straight line or curved. There are different properties. And from this electric lines of force, we can define flux quantitatively, qualitatively. Quantitatively, it is simply the dot product of electric field and the surface through which is coming out. And after these definitions, we can state the Gauss law, which is nothing but the flux coming out of a closed surface is equal to capital Q, charge enclosed by the surface divided by epsilon naught, that is absolute permittivity of free space. And with that, we can prove the Gauss law also for as the arbitrary shapes are shape of surfaces, and thus we will left with some numericals to understand more about this Gauss law. So in this particular example, we are taking a cube. Cube means all the sides are equal. The side is a capital L, and what is the flux coming to each face of the cube? We have seen the 6 faces are there. Out of the 6 faces, what is the flux coming out of only one surface? So the answer is here. For a whole cube, it is the flux is capital Q by epsilon naught. And since this is a statement, as the charge is at the center, electric flux is symmetrically distributed among all the 6 faces. So that means capital Q by epsilon naught is the total charge, total flux, and since the charge is at the center, so all the surfaces will get equal amount of fluxes. So that means we have to divide it by 6. So ultimately, flux with each face is capital Q by 6 epsilon, just to divide this by 6. Like coming back to the second question, find the flux for a surface area as if electric field E makes an angle of 30 degree with a surface. Suppose this is a surface and electric field is making 30 degree angle here. Now the question is that what is theta now? That is the important thing. Basically, the theta is nothing. It is the angle between the electric field and the normal to the surface. Now in the question, electric field is making angle 30 degree with the surface. That means it is not making angle 30 degree with the normal. With the normal, it is making actually 60 degree, because 90 minus 30 is equal to 60. So this is the main thing, that the angle between the normal to the surface and the field is 60 degree. So 90 minus 30 equal to 60. So you can find out the flux then. F equal to E dot S, the basic definition, and E S cos theta. So theta is just simply 60 degree here. So while solving this kind of problems, we must be very cautious regarding angle theta. This is the most determining part. So to get it, actually we remember that theta is not the angle between the electric field and the surface. Rather, it's the angle between the normal to the surface and the electric field. So you must remember the word normal to the surface while calculating the angle. So as in this example, here although 30 degree angle is made by the electric field with the surface, but it is actually 60 degree with the normal to the surface. The electric field is 90 minus 30 equals 60. So as analyzed like that, the answer is cos 60 here. Yes, cos 60. So with this we are left with some assignment here. So this has already been discussed, and you can try at your home whether the area is in vector, or if it is not a vector, how can I see it? Then what is electric lines of force definition? Some of the important lines of force for two unequal negative charges are like a dipole, just like closed charge configuration, always depicted in the figure. And some of the properties of electric lines of force, and the flux definition of flux with both qualitative and quantitative way. And finally the statement and the proof of Gauss law, which is all these things are here. Listen, so you can try it at home and then can understand the topic very well. So that's all for today. Thank you for watching the video.